2024 AP Precalculus free response. This one is a calculator section. Number 1, the figure shows the graph of the function f on each domain negative 3.5 to 3.5. The point negative 3, 1, 0, 1, 3, 1 are on the graph of f. The function g is given by like this. Okay, so let me mark it this one 3.1 on the graph because this is graph of g. Graph of f. So negative 3, 1 is right here, 0, 1 right here, and then 3, 1 is right here. Okay, the first one, a, the function h is defined, h of x is a composite, g composite f of x. So g of f of x, find the value of h of 3 as a decimal approximation or indicate it is not defined. Okay, so h of 3, so you plug it in simply 3 here, right? So g of f of 3. Okay, so f of x is graph of f there. So f of 3 is right here. So that y value is 1. So when you substitute 1 instead of f of 3, now g of 1. So 1 will be now x value. So you plug it in into this one here, right? So 2.916 times 0.7 to the power of 1. So once you plug it in the calculator, you will get around 2.041. 3 decimal places is a standard in AP test. So make sure you put it like that. Now, second one, find all values of x for f of x is 1 or indicate there are no such values. Okay, f of x equals 1. Okay, so in the graph, where is f of x is 1? Right here, here, here. The one I put in here. So that value, x value is negative 3, 0, and 3, right? So you have to say negative 3, 0, and 3. Okay, those are 3 answers from the graph. Now B, find all values of x as a decimal approximation for which g of x equals 2 or indicate there are no such values. Okay, so you substitute 2 into this expression, which is g of x. So 2 equals 2.916 and 0.7 to the power of x, right? And then graphing calculator is required, so you can just type it in, solve function in if you have a TI Inspire, or if you have a decimals or your other calculator, you can graphing, right? You can graph 2 and or this exponential graph and then find the intersection. Okay, so if you do that, so x is around 1.057. Okay, so just use a calculator for that. Second, determine the end behavior of g. X increases without bounds. So that means as x increase without bounds means it goes to infinity. Express your answer using mathematical notation of limit. So that limit, you have to say limit x equals to infinite g of x, right? Okay. This one, since your b value is 0.7 is between 0 and 1. So if you think about exponential graph, it's going down, right? It approaches to 0, keep going down. So this one eventually it will go 0. Okay. The reason why, because your exponential graph looks like this, right? And then as x approaches to infinity without bound, then the y value approaches to 0. Now C, determine f has an inverse function. Okay, how do you know f has inverse or not? Simple way is do horizontal line test, right? So if you hit only once, then you're gonna have an inverse function. But this specific function, you're gonna have a 3 intersection or sometimes a 2 intersection like that. Then you're not gonna have an inverse, right? So this one is it fails, the horizontal line test. So you have to say this one no inverse function, no inverse function, right? And then give a reason for your answer based on the definition of function on the graph of y equals f of x. So you can say, there are more than one input values mapped, one output value. So, like I said, let's say those are that like example. For one output values, which is when y equals 1, you have a 3 different input, right? So if you have more than one input value for the same output values, that means it doesn't have inverse function. So you can say, because there are more than one input value mapped to one output value. Okay, there will be, or you can say it fails horizontal line test, right? Horizontal line test. Okay, but this is a more official answer. Okay, let's move on. Number 2. Okay, still calculator required section. On the initial day of sales at t equals 0 for a new video game, there are 40,000, okay, 1,000 units, so 40, of games sold that day. 91 days later, so when t equals 91, 76,000. So you can have 2 points, right? 0, 40, and the other one is 91,76, like that, in thousands. The number of units of video games sold on a given day can be modeled by the function g, like this. Okay, so let me highlight it. We have a logarithm function like that, where g is a number of units sold in thousands on day t since the initial day of the sales. Okay, a first one, use the given data to write two equations and can be used to find the values of for constant a and b in the expression for g of t. So you simply plug it in those 2 points, right? So you plug in, first of all, instead of g of t, you plug in 40. So 40 equals a plus b times ln of t is 0, so 0 plus 1 is 1. So leave it like that. That's one equation. The other one, when you plug it in second point, 76 equals a plus b ln of 91 plus 1 is 92. So that's the answer for I portion, right? So those are two equations. Now find the AB for the second portion as a decimal approximation. Since ln1 is 0 here, so A itself is 40, okay? And then you plug in this one into here, so 76 equals 40 plus B ln 92. So now from here, b is what then? 76 minus 40, which is 36 over you divide by ln 92, right? Like that. And then once you plug in the calculator, this one is approximately 7.961, 3 decimal places, right? Those are b value, and a value is this. Okay, those answers. Now using given data, bi, average rate of change, okay? They ask you average rate of change of the number of units of the video games sold in thousands per day when t equals 0 to 91 days. Express your answer as a decimal approximation. Show the computation that lead you to your answer. Okay, so your average rate of change is 0 to 91 is a g of 91 minus g of 0 and 91 minus 0. So we already found out g because AB we already found. So let me write down here g of t equals A was a 40, B was a 7.961, and then ln of t plus 1. Okay, so that's my of g of t. So let's say you plug it in, right? You plug it in this 91 into here, this equation. Then I'll write down here, and also minus g of 0 is also you plug in 0 here, and then you write down. Okay, so g of 91, once you plug in 91 into t for g of t, I did it ahead of time, so 75.998. Okay, I want to actually put that in, minus G of 0 is a 40 over 91, right? So in 3 decimal places, once you plug it in, you get 0.396. Okay. What is unit? Thousands unit per day, right? 1,000 unit per day. Okay. That's the average rate of change. So they're gonna sell point 0.3, so 396 video games per day. That's what it meant. Now use the average rate of change found I to estimate the number of units of the video games sold in thousands on day T50. So show your work. Okay. So the way you do is use this equation y equals then your initial g of 0, initially g of t, right? G of t is a 0, so g of 0 plus your average rate of change, which is r, times number of days, right? So okay, what was the g of 0? G of 0 we found the 40, and then your average rate of change r is, this is basically r is 0.396, and how many days? It said t is 50, so 50 days later, how many units sold? So now once you type in the calculator, but here, even if we found the your r is 3 decimal places like that, when you use this one here, just copy and paste the full r value. So 0.39 instead of 6, you can actually put 5582, things like that. You copy and paste that one and times 50. Okay, only your final answer I want to round up to thousands decimal places, 3 decimal places, not in the middle. Okay, so when you put that in the calculator, you get like 59.780, right? That's the same answer as a collegible answer, that thousands unit. So 1,000 unit. Make sure you write down the unit. Okay. The third one, let A of t means approximation, using that average rate of change. Estimate the number of unit videos sold in thousands using the average rate of change found in I. So this is a approximation. So A stands for approximation when t equals 50. In second, and it can be shown that your approximation is less than actual model, which is a g of 50. Okay. So explain why in general A of t is less than g of t for all t, as long as t value is between 0 and 91. So if you actually graph it, just I want you to think about it. I'm graphing this one here, original this one. So when t equals 0 is a 40. So let's say you start from 40 here. Okay, and then ln graph. ln graph is like this here, right? That's ln, part of ln. So let's say this one 0, and then let's say here 91, right? And then if you use a average rate of change between this point and that point, so your graph looks like, that secant line graph looks like this, right? So that means like let's say this is a t is between 0 and 91. So that value is using that approximation, using average rate of change. So that's a of t. And if you go up, so that point right here, that's actually g of t, right? So it shows your g of t is higher than your approximation, right? Using the secant line. Average rate of change of that 2 point is a secant line. So t, right? As long as your t value is between 0 and 91, right? It kind of shows in the graph like that. Or you can write it down like the estimate A of t. So you can write down the estimate A of t. But I want you to graph that one and show them, right? You completely understand. You can visualize your answer. So your A of t is the y value. Y value of a point on the second line, right? Second line that passes through, passes through, I don't know, space, passes through 0 comma g of 0, and also 91 comma g of 91, right? Like that. And then, so you can say because the graph of g, is concave down, right? Is concave down, as you see. So you see that g of g is a concave down. Then the graph of g, and then you can, this is concave down. So you can say the secant line, the approximation, secant line is below the graph of g of x, g of t, right? So I show the graph like that. So that will be justification. Now C, I don't know, you can see clearly. So maybe I should erase it. Yeah. So let me, I believe you already copied down. So let me erase this is description. So like here. Okay. Oops. Yeah. Okay. Now, so the makers of video game reported the daily sales of the video game decrease. Okay. So actually, the sales, the daily sales decrease each day after t equals 91, and they explain why the error of the model increases. Why error increases after 91. Okay, so let me explain graphically then. So error means that the model G, it follows this logarithm graph, right? So anyway, it keeps on going, right? But actual sales, so we don't know the graph of the actual sale, but probably it'll go down, right? But these approximations keep going up anyway. So their error will keep on increasing, right? So these actual sales is at that decrease. And then your approximation, I mean, the G of T, the model G of T keep increasing. So their error, the gap is error, right? So that one is to keep on increasing, okay? That's the concept. So you can say for t is greater than 91, the daily sales are decreasing, right? Daily sales is decreasing because that's the description, and G of t is increasing, right? Increasing. That's also the description. Therefore, the absolute value of differences between the actual and the sales predicted by G of x, right? G of t, the sales predicted by G of t is increasing. Okay, there will be explanation for that one. Okay, so that's up to second question, and then for the next video, I'm gonna make it 3 and 4.